You've seen it on the grocery store shelves. You've probably heard health influencers talking about it. I'm talking about alkaline water. Now, there are some pretty big claims out there, but one is, well, bigger than all the rest. The idea that it can help fight cancer. Today, we're going to put that specific claim under the microscope and see what the science actually says. Let's dive in.
I mean, it's a huge question, right? And it's one that carries a lot of hope. Could something as simple, as fundamental as the water we drink actually make a difference in one of the toughest fights there is? It's a really compelling thought, but we're here for the evidence. So let's see what it tells us.
All right, so to really get to the bottom of this, we need a game plan. First, we'll look at the big promise behind alkaline water. Then, we're going to explore the three main scientific theories for how it might work. After that, though, we're going to hit a very important reality check before we finally reach our verdict. Is this hope or is it hype?
Okay, so first things first. What's the big idea here? What is the promise that's being bottled up and sold to millions of people? Let's break it down.
So let's start with the absolute basics. You might have to dust off your high school chemistry for this one, but it's pretty simple. Regular water has a neutral pH of 7. Alkaline water is just water that's been treated to have a higher pH, usually somewhere between 8 and 9. That just means it's less acidic than the water you get from your tap.
And here it is. This is the core claim, that by drinking this slightly less acidic water, you can actually change your body's internal environment, make it less hospitable for cancer. The theory is that you can literally create conditions inside your body that might slow down, or maybe even stop, tumor growth.
Okay, so how could that possibly work? Let's dig into the first major scientific theory, which is this idea of creating a hostile environment for tumors just by changing your body's pH.
Now, to get this, you need to understand something called the tumor microenvironment. The key thing to remember is that a tumor isn't just an island of rogue cells. No, it's more like its own little neighborhood, a complex ecosystem, with its own supply lines and local weather, if you will. And that neighborhood is absolutely critical for the tumor's survival and growth.
This slide really gets to the heart of the theory. See, on the left you've got the typical situation. Tumors are busy, and all that activity creates a very acidic little bubble for them to live in. In fact, that acidity helps them thrive. So the theory, on the right, is that if you introduce alkaline water, you might be able to neutralize some of that acid, basically making the tumor's neighborhood a much tougher place to live.
So that's the pH theory. But there's a second big idea, and this one is all about cooling things down. Specifically, we're talking about inflammation.
It's been known for a long time that chronic, persistent inflammation is like pouring gasoline on a fire for many types of cancer. So, naturally, anything that might have an anti-inflammatory effect is a huge area of interest for researchers.
And this is where it gets pretty interesting. In lab studies, we're talking about cells in a dish here, alkaline water has been shown to dial down some key signals for inflammation. You see them listed here. TNF-alpha, IL-1 beta, and COX-2. Now, you don't need to remember the names. Just think of them as the body's fire alarms for inflammation. And in the lab, alkaline water seems to quiet those alarms down.
Okay, so beyond pH and inflammation, there's a third potential pathway, and this one takes us into the body's highway system, the blood vessels that tumors rely on to grow and spread.
Back in 2021, a study looked at exactly this in mice with melanoma. And I have to say it again because it's super important. This is a study in mice, not people. But the question they asked was, could alkaline water somehow protect their vascular system?
And the results were, well, pretty intriguing. The mice that were drinking the alkaline water appeared to have healthier, stronger blood vessels. The cells that lined those vessels just seemed to be functioning better overall.
But here it is. This is the result that really turned some heads. The mice on alkaline water had less cancer spread to their lungs. That is a big deal because metastasis, the spread of cancer, is one of the deadliest aspects of the disease. And this study suggested that, at least in mice, alkaline water could help reduce it.
Okay, so let's recap. We have some promising theories from the lab. We have some interesting results from animal studies. But now we get to the most important part of this whole discussion. Does any of this actually hold up in human beings? This is the reality check.
And this right here is the single most important takeaway. I'm going to read it directly from the source material because it couldn't be any clearer. No clinical trials have conclusively demonstrated its ability to prevent or treat human cancer. That's the bottom line, full stop.
And here's the why behind that statement. The human body isn't like a swimming pool where you can just toss in some chemicals to change the pH. It's an incredibly sophisticated machine. Your kidneys and your lungs work around the clock, 24/7, to keep your internal pH locked into a very, very narrow and stable range. They are exceptionally good at their jobs.
So you end up with this stark contrast. On one side, you've got this preclinical evidence, lab work, mouse models, that suggests some theoretical benefits. It's interesting stuff. But on the other, more important side, you have the human evidence, which as of today is basically a blank page. There are no conclusive clinical trials to back up these claims in people.
So where does that leave us? After looking at the theories and the evidence, or lack thereof, is alkaline water a source of real hope, or is it just clever marketing hype?
But let's be real for a moment. A big part of the reason this trend took off is simple. Unlike a lot of other experimental treatments, alkaline water is everywhere. You can go buy it right now at the grocery store. Its biggest advantage is its accessibility.
And you can get into it at different price points, right? A simple filter pitcher might set you back $50 to $200. But if you want to go all in, a fancy ionization machine for your kitchen could cost you well over $1,000.
So let's just state the final takeaway as clearly as possible, based on all the science we have today. The potential benefits of drinking alkaline water for cancer care are, as of right now, completely theoretical. They are not supported by evidence in human beings.
And that leaves us with a much bigger, much more difficult question. We all want and need hope, especially when facing something like cancer. But the scientific process is often slow, and it's methodical. So it forces us to ask, in that gap between a promising theory and proven science, where do we choose to place our hope?